Hi, 715 students. Yesterday we counted slope on a graph. Today I'm going to teach you a little bit more sophisticated of a way of doing this using the slope formula. I think you're really going to like this because it's pretty standard practice and you're just plugging in numbers. Before we get started, I just want to remind you that an ordered pair is always x, comma, y. So you're going to need that for the slope formula. Our slope formula is written here for us. Remember, m means the slope. Yesterday we were counting rise over run, and I talked to you about how that meant the change in y over the change in x. Today we're going to use this last part, this slope formula, to subtract the two y's and subtract the two x's to get our slope. So I'll show you what I mean by that in number 1. We're given two ordered pairs, 2, 3, and 4, 7. The first ordered pair is xy, and the second ordered pair is also xy, right? Just like I showed you up here, x comma y is our ordered pair. So I'm going to choose whichever ordered pair I want to be x1, y1 because that's our first ordered pair. And I'm going to choose whichever one to be x2, y2 because that is our second ordered pair. And by first and second, I just mean that there are two of them. It does not matter the order. I'm actually going to make this our first one and this one our second one. It does not matter the order. You just have to be consistent with the x and y being from the same ordered pair and x2 and y2 being from the same ordered pair. Okay, so our formula is y2 minus y1 over x2 minus x1. The reason why I chose the second ordered pair to be number 1, actually I kind of did it back, it doesn't matter. Anyway, it doesn't matter which way you do it, so I just wanted to show you that. So now we're going to plug in numbers here. So if I do a little bit of highlighting to hopefully make sure you understand, this is x2, so that number is going to go here. This number is y2, so that number is going to go there. This is x1, so that's going here. And this is y1, so that's going here. So let me fill in those numbers. Y2 is 3 minus y1 is 7 over x2 is 2 and x1 is 4. So when I subtract this, 3 minus 7 is negative 4 over 2 minus 4 is negative 2. So here's our slope. Excuse me. I am going to simplify this because we have two negatives. So two negatives we know make a positive. So I'm going to ignore my negatives now. 4 over 2 can also be simplified to either 2 over 1 or just 2. So our slope here equals 2 or 2 over 1. If I changed the order, I would still get 4 over 2. It just would both be positive. It doesn't make a difference because it ends up being positive either way. All right, let's try this one more time. I'm going to jump down to number 4. So I'm going to make this x1, y1, x2, y2. I find it very helpful to label them to keep your work organized. We're going to take y2 and subtract y1 over x2 minus x1. Okay, I have two sets of double negatives. Double negative actually means plus, right? Remember us practicing that long ago? So this is actually telling me to do 3 plus 3 and 4 plus 2. In the numerator, 3 plus 3 is 6, and in the denominator, 4 plus 2 is also 6. 6 over 6 can be simplified to 1, so our slope is 1. Okay, I want to show you really fast that the order does not matter. Even with, never mind, I'm not going to show that part, but I can show you really quickly that this order does not matter. If I switched these to 2 and 2 and this to 1 and 1, I'm going to show you how we'll get the same answer. So it'd be negative 3 minus 3 over negative 2 minus 4. Negative 3 minus 3 is negative 6. Negative 2 minus 4 is negative 6. So we would still get a positive 1. So in case you were wondering, the order does not matter. It doesn't matter which ordered pair you choose for which one, but the ordered pairs should end up stacked on top of each other. That just glitched really crazily. Oh, sorry. This one is actually just positive 3, 4, or 4, 3. So you can see that they're stacked in either case. Okay. I'm not going to show you any others. Actually, I changed my mind. I am going to show you 5 and 6. Okay, so in 5, let's do this. X1, Y1, X2, Y2, Y2 minus Y1 over X2 minus X1. On the top, we're going to get 0, and on the bottom, we are going to get 5. 0 over 5 is the same as 0, so in this case, the slope is 0. In number 6, we have, let me label them really quick, 3 minus negative 3 over 2 minus 2. So we have 6 on top. Remember, the double negative means plus, so we actually had 3 plus 3 to make 6. And 2 minus 2 is 0. Remember what we talked about earlier this year? When we have a 0 in the denominator, that means that this is undefined. So our slope here is undefined. So it is possible to get a 0 slope, and it is possible to get undefined. I showed you what each of those looked like yesterday. This would be the answer that you would give. On slide 2, there is the same exact thing. The questions in numbers 7 and 8 say, what is the slope of a line that passes through? And then it gives you the 2 points. That is the same thing that we were just doing. I just didn't have the questions. And then there's also a graph at the bottom like we practiced yesterday. I'm adding slide 2 as part of your independent. Then you have slide 3. Let me back this up here. Ooh, the wrong independent got linked here. I'm going to change your independent so you'll have independent that actually matches what you did instead of what is here now. All right, good luck.